Okay, so we're recording. It's 10:30 Sunday night. What kind of questions you guys have? So you can either type in the chat box or you can ask them through the audio. But not everybody at once. Okay, there we go. So Moulet's asking about number 3. So that's this one, yeah? Yep, so we can go through both of those. We'll have plenty of time, it looks like. Yeah, so what you want to do is you start out, we look and we say, okay, it's going to be a rigid body type of problem, right? Oh, so Moulet means, is that this one, Moulet? Okay. Yeah, so what you want to do is you're starting things out is you say, well, is this going to be an F equals MA type of thing? Am I given all the information so it's just a kinematics? Or is it going to be just a, like a work energy, right? So what type do you guys think it is? Yeah, so if you look at it, we're starting off with one specific position, right? And then we're going to move to a second position, right? And it's an 8 by 8 foot door, right? So basically, that's going to be our position 2. And right where it is here is our position 1. Does that make decent sense, everybody? So I drew out position 1, position 2. We said it was work energy, right? So then we just have to go through and figure out, all right, well how is this whole thing going to move then? Okay, so how I like to do is I just start everything off with like a T1 plus a VG1 plus a VE1 plus a U1 to 2 equals T2 plus a VG2 plus a VE2, right? So we've got all these that are listed. So you know what I usually like to do is say when stuff goes to 0, right? So it's starting from rest, right? So what does that mean? That T1 is going to be 0, right? And then where do you want to set your datum? Okay, so we can set our datum right here, right? That's fine. You could have set it at the floor as well, right? Kind of pretty much up to you, right? Wherever you want to set that thing is fine. Okay, so then do I have a VE1?
No, it needs to be here.
Okay, so there's no VE1 because it says it's not stretched at first, right? So the VE1 is going to go 0. Do I have any work to look at besides things from a spring or things from gravity? Yeah, that answer is no, because I don't really have, say, like an applied force, or we're not doing friction or anything like that. Okay, so we won't have a U1-2 type of term here, right? So that's going to go to 0. And then do I have a T2? Yeah, so I'm going to have a T2, right? Because that's the velocity as the thing hits the door. Now, the one thing that's a little bit tricky is once that thing becomes vertical, then what's going to be true about its omega? Right, because just after that thing goes through, then A is going to be constrained to just move up and down, and B is going to be constrained to just move vertically. So that means the only thing I have is a 1/2 mv squared. So I think that's probably one of the hang-ups it might be, because the VG term's not too bad. Right, so the one thing here I think that's gonna be a little bit confusing is that it's not going to have any rotation right as soon as point B hits the top part there. Okay, it's an 8-foot garage door. So everybody see that that's just going to be vertical then? Okay, and then the other thing that might be a little tricky is how far, you have to figure out how far is that spring going to be stretched out once we're down at the bottom in position 2. Okay, so the question is, how far is the spring going to be stretched out there at position 2? Okay, so we got some people saying 4 feet and some people saying 8 feet. Okay, so how far will point A move? Yeah, so, well, point A is just going to go from here to here, right? So it's going to go all the right. So it's going to go, I'm sorry, point A is going to go from here all the way down to there, right? Okay, so if that's 8 feet, then how much of this thing is being pulled, right? If that's pulled down 8 feet, then this is going to be 4 feet on either side. Okay, do you remember doing that with how we have the, when we did those pulley problems back in 212? Okay, other question, does that make sense to everybody? The spring's only going to be stretched out 4 feet now. Um, 2t equals f fx. Oh, okay, I see what you're saying. Yeah, but you don't even have to worry about that, Moulay, because all you have to do is for VE1 here, right? That's just 1/2 kx squared, right? And we've been saying, so this is, how much more is it stretched now, right? And it wasn't stretched before, so now it's stretched by 4 feet. So this is, the x is just going to be 4 feet there, right? You know what k is, you know what the half is. The g should be pretty straightforward to figure out, right? So I think the two sticky points here are the pulley. Oh, were there two? I'm sorry. Yeah, you're right. There are 2 springs. Sorry. Thanks. Okay. So what I try to do is get you about 70% of the way there as we chat through. Okay. So, but hopefully you're all kind of making a good effort at it, because I think it helps once you really have to struggle with it a little bit, and then once we talk about it, I think that helps out. So the question is VG1 0? What does everybody think there? So we've set our datum. Well, 1 isn't it? It depends on where you set your datum, Aladad. So if you set it up where G is, right? So I would say with how I set my datum, if this is position 1 up at the top, right, that this distance is now my H1 or my Y1. Okay, so then I would say, no, VG1's not going to be 0. But what would be 0? Not VG1, but VG2. Well, Aladad, somebody else told me before they wanted to set it there how I've drawn it. So right at the CG of where 2 is. So hold on, let me put a G there. That might help too. Sorry. Okay. All right, I think the next question that we had was number 1. Right, so people were wondering about how to set that one up, right? So we talked about how this would go in class. Remember that this is going to be a kind of a combo problem, right? Because just like we worked out on the Sharpie test, right? This is a combination where we're going to need to use work energy to figure out what the omega is as a function of position, right? As we had talked about at one time before. So if we draw out, right? So here's our, let's start out just drawing our FBD and KD. Then we've got, forces going like this, right? And you could do this in both. You could have used normal tangential, or you can use X, Y, Z. Okay, it's really kind of up to you. So I would draw it out like this. This is our MAGX. And remember, I just put stuff as being positive. That's MAGY, and that's our IG alpha. So there's our FBD KD, and I'm just going to call that theta, and then this will be L over 2, and then I have an MG as well. Okay, did everybody basically have that? Are there questions? Did I leave anything out? Oh, I'm sorry. Yeah, let's use A. I'm just so used to doing O for a fixed point. Sorry. All right, so what's our next step if we're doing kind of an F equals MA type of problem? Yeah, so we just go through our sum of forces in X equals MAGX. Our sum of forces in Y equals MAGY. And then we do our sum of moments. And could I use sum of moments about A equals IA alpha for this problem? Yeah, because I have a fixed axis of rotation, right? I don't have to do that. I could also do, it'd be the same thing. And remember, this has worked out both ways. So if you're confused by this problem, you can certainly go look at it on the it's almost the exact same one as the Sharpie one, but there I just kind of saw that at one point, right? So we could also do this problem. Right, that would also give us what we're looking for. Okay, either one of those you can use. So I kind of like the IA alpha because that ends up being just a 1/3 for slender rod ML squared times alpha, right? And we could also have used right? We could also use sum of moments about G equals IG alpha. So any of those 3 moment equations is valid for this problem. Okay, and then the moments, of course, are going to be a function of theta. Does that make sense, everybody? So like when theta is 90 degrees, then the sum of the moments is going to be 0. Okay, so that would be when it's totally vertical. Okay, so we had talked before, we do, right, sum of forces, I'm sorry, first we do our sketch, then we do sum of forces, sum of moments, then what's our third step? Yeah, we pretty much end up doing kinematics, so what I really want to know is AG, right? Because that's what's in my sum of force in X and sum of force in Y. So if I want to know AG, how can I write a kinematics relationship for that? AG equals? Yeah, so I can go A of A, right, plus I can do omega cross R G with respect to A, all right, plus alpha cross R G with respect to A. Okay, so we've got all those. Okay, let me pause for a second. Does anybody have any questions so far? Okay, so my acceleration of A is going to 0, right? That's a pinpoint. Where can I get my alpha value? Yeah, kind of FBD and KD, but which one specifically? I got this guy right here, right? So that's going to be this alpha that I can feed right into there. Right at the very beginning, what's my omega, right, when it's horizontal there? Yeah, the omega at the beginning is 0. Okay, so you guys in the library, that the IG is 1/12. So if you use the bottom one right here, then yes. But if I use IA alpha, the one down here, then IA about a bar end is 1/3 ml squared. Okay, so Ig, the one right down here, Ig is equal to 1/12 ml squared, but Ia about the end is 1/3 ml squared. Okay, so if I was just starting off asking you what the forces were at the very beginning when it's at rest, right, then I would just have the AG would really only be a function of the alpha. Right? But if I want to know it at kind of any time, right, then how can I find omega as a function of theta? Yeah, I'm going to have to use work energy. So I'm going to go up here. I should have probably given myself a little bit more room, but I'm going to draw this as position 2, right? That's going to be my theta angle there. Okay, so this is position 1. This is position 2, right? And then, of course, my main point that I'm always worried about is my CG, right? That's our critical point is CG. And now I just do work energy. So the same thing that we did before, right? Where I can do T1 plus VG1 plus VE1 plus U1 to 2 non-conservative ones is equal to T2 plus VG2 plus VE2. Okay. Right, so we can define what our, the critical parameters here now are going to be our, right, is really good. This is going to go to 0, but our critical one here is this T2, right, because T2 is going to give me whatever my omega is, and omega is what I can plug in now down here. Okay. Okay, so basically I can use work and energy to figure out the omega at any time, right? And then from that omega, I can now substitute that in to figure out what my AG is at, really I should say any position, okay, any position theta. Does everybody understand? So basically this is going to give me omega as a function of theta. Right, so this is going to give me omega as a function of theta. That omega I can plug in down here. My sum of moments about A is also going to be a function of theta, right? Because it's going to change depending on how far away the mg is. Okay, so Ethan's asking if T2 has a VG term. So you're saying the second. Well, so what does that depend upon? Oh, I'm sorry. I thought you were meaning VG, like the one that's up there, like the VG1. So that depends. So you're asking about the, okay. Yeah, velocity of the center. So, that depends on which one you want to use, right? So you can either use this T2, you can either use 1/2 IG omega squared plus 1/2 MVG squared, right? Or what else could you use? Right, you could also use that one. Okay. And I think we showed in class, right, that those two things are equivalent. So certainly the center mass here does have a velocity, right? But you can either use either of those two expressions for T2 will basically incorporate that. Okay, any more questions about this one? T2 gives you omega. Okay, so there's a question, Ben, saying, how does T2 give you the AG? Well, it gives you the omega, so now you can figure out what the normal acceleration is, right? And then from the sum of moments equation over there, you get alpha. So if you know if you figure out what the normal and the tangential acceleration is, then you have it. Sure, AGX and AGY are unknown. So if you go to this expression here, right, then you get alpha directly from that. If you use this expression down here, right, it actually ends up that you're that you'll just have more equations and more unknowns, and you're just going to have to solve that algebraically. Okay, so you could use your, say, like matrix algebra for that. Yeah, you always have to use point G for potential energy. Okay, that's always talking about your center of mass. It's how high that's going to be. Okay, any more questions about this one? Okay, so I think the next one that we had a question that people had a question on was number 3, and so that's this one, right? So how we want to start out looking is we say, all right, do I have enough? Is there enough stuff in terms of like omegas and alphas and things that it might just be a kinematics problem? Of course, as I look at it, the answer is no. I'm going to have to worry about forces and how they come into play, right? So this is going to, as I look at it, it's not just kinematics, it's going to be kinetics. Then I want to look at it and I think about if there's an impact, right? If there's an impact or if there's a time, then that's going to be angular impulse momentum, and that's what we'll be talking about tomorrow. And it doesn't have any of that. So then I look and say, okay, am I looking at 2 different velocities and 2 different positions? And no, it's not saying what happens like when that bar is along the x-axis, right? When it's moved around to there. So we wouldn't have that. So then I look and say, okay, is it asking me about sort of a relationship between forces and moments and accelerations? And yeah, that's what it's going to be. So this is just an F equals ma, or kind of Newton-Euler formulation. Okay. So knowing that, what's our first step in a problem like this? Yeah, so we're going to do our FBD and our KD, right? So we can draw this guy out like this, right? We've got our CG there. And remember, this is hopefully you can sort of tell by how it's drawn out. This is actually in the horizontal plane. Okay, so that's on a flat surface. Okay, so we do our FBD and our KD. So does it say anything about a coefficient of friction? Nah, so probably we could have been a little bit better and wrote written, sorry, smooth slots there. But since we didn't give you there, you could sort of write on there, assume it's frictionless, right? So what's the force at A? Just be a simple kind of A in the X. And then at B, I can draw a B, a BY. Anything else I need to do for the FBD? Yep, so I got to put on this M. And then for the KD, okay, so I draw out those. Does that make okay sense to everybody? Okay, so I've done my FBD and I've done my KD. What's my next step? And I'm just going to write this as a vector one now. Can I do this? So sum of moments about A equals A alpha. Tommy says no. Anybody else? Nope, not a fixed axis of rotation, so I cannot use that. I can use some moments about G equals IG alpha. Or I could use either sum of moments about A or B, and I could do an IG alpha plus R from A to G cross MAG. Right, so the only advantage of that is that I can now get rid of A. If I'm sum of moments about A, then I get rid of the force up there. Okay, then what's my third step? Yep, so now I got to do kinematics. All right, so what points might I want to relate to one another? Okay, so we could do like like AG and A. Which did you mean by O, Katie? Oops. Okay, gotcha. Right, so we can do this. Okay, and what's omega? It's 0 because it's starting from rest here, right? So the bar is at rest when that thing's applied. Now, it's going to end up that this is going to introduce another unknown, right? So typically how these things will go a lot of times is, you know, if we look here, we might have a couple forces, like we don't know what A is, so I'm going to write out my unknowns. And this is a good habit to get into. I've got AX. I don't know what BX is. I don't know what AGX is. I don't know what AGY is. And I don't know what alpha is. Okay? Out of these, I get 3 equations, right? So, and it's almost always 3 independent equations, right? Sum of force in X, sum of force in Y, sum of moments. Okay, out of this, I get 2 equations, right? Because I have X and I have Y. Okay. The problem here is I've introduced another unknown, right? So my other unknown is the acceleration of A. Right now, luckily for this problem, it's only in one, right? It's only in one direction because A is going to be constrained in the Y direction. Right? So that means, though, I still have only 5 equations and I have 6 unknowns. Okay, so I'm going to have to come up with some other relationship, and another sum of moments equation won't do it for me. All right, so what else could I do? Yeah, so I can now do acceleration of A equals acceleration of B plus all our stuff, right? The omega and the alphas in there. Okay, now that introduces two more equations and one more unknown, right? Because I don't know what AB is. Okay, so that'll be enough. Now, the other thing I could have done is A of G equals A of B plus all that stuff, right? But essentially, I'm only going to be able to use two of these relationships as well. So I'm only going to be able to use two of those that are independent. Okay, and I could also switch those around, like the order doesn't have to be this. It could be acceleration of A equals acceleration of G plus omega cross R plus alpha cross R. Okay, but basically I need to come up on this one with two more expressions for accelerations. Okay, so two out of those three will solve it for me. Questions there? Okay, more questions. Didn't we do 4 already? Was that this one? Okay, so this is the one I think I gave you a pretty good hint on this one in class, right? So if we look at this, we've got the uniform, that's all you have to do is work energy. Oh, do you mean, okay, so what are the steps here again? What do we do for any of these kinetics problems? Yeah, so let's go through. What's the first step again that we always do? Yep, position 1, position 2, right? So it sounds like you've done that already. Then what's our next step? We do our work energy, right, or whatever equations of motion are. And the third step is kinematic. So you just asked me, how do you relate VG and omega? Well, that's how you do it, right? So how would you work through the kinematics? What points could you relate? Yeah, so we could do like V of G equals velocity of B plus omega cross R G to B. Okay, so that's going to help some. Do I know anything about the velocity of point B? Yeah, so this is going to be some sort of like VB times some sort of cosine theta in the I and minus VB sine theta in the J. Right, because we were told which direction that has got to be going along that edge there. Okay, so I've got a VGX, right? Unfortunately, I got a VGX and a VGY. right? So that's kind of three unknowns in just that one equation, right? So how can I get another relationship? Yeah, so now I either have to do, maybe I do now VG equals V of A plus omega cross RG with respect to A. Sorry, I should make that G better up there, sorry. Okay, or I can use V of A equals velocity of B plus omega cross R of A with respect to B. Okay, so I can use any of those, right? So, and it's just like the one we did before. We're going to end up needing to just use two of those kinematic relationships. Okay, and you're going to have to make sure you remember that you really want the VG is going to be VG, right? That you want is really square root of VGX squared plus VGY squared. Because it's a scalar equation. Yeah, unfortunately here you've got to use the kinematic constraints there because you're going to have to use both B and A because the way they're constrained there, A is not moving in the Y direction. Right? So, yep, you end up having to use two of them. And I think I tried to give you that hint in class. Sure. More questions? Okay, so is this one number 4, right? So the difference between velocity G final and velocity A final on number 4. So yeah, Alec, they will be because there's no omega since now that thing's really constrained to just move in that slot, in that vertical slot. So as soon as it's down in this full column right here, then that bar is only moving up and down. You know, it might be easier if this was like a foot longer and then you could sort of tell. But as soon as it's dropped in at that kind of instant, then it's no longer rotating. It no longer has an omega. So that means if I did like, if I wanted to relate the two, I could say VG equals VA plus omega cross R, but omega 0, so VG and VA are the same. Yeah, so oh, I'm surprised with them. Did you find one for a half cylinder by any chance? Because then it doesn't matter really how long it is in the end. Let's see here. Let me just check and see what I had. Yeah, so let's see. I have that it is the mass. Let's see here. Oh, there we go. Yeah, so it's going to be the mass times the radius squared over 2 minus the, I've got the mass. Yeah, because that's just, it's actually kind of like a, you know what that is it's like an MD squared because you're just doing instead of the whole one, right? So basically all that equation's doing is it's kind of like if you did this whole circle, it would be an MR, it would just be, um, uh, hold on, sorry, I'm just looking at my other ones there. It's a 1/2 MR squared, but then you've got to move it because the mass is a half of what it would be there as well. So you're really kind of moving it down to the CG right here. So that's what the minus deal is that you have there, the minus M, because the distance here, right, is 4R over 3 pi. Right, so it's really like you're using the that I of O equals I of G plus MD squared, right? So this is your D, and then your M is what you wrote up there, Tommy. So that's correct. Yeah, because what you're trying to find is G, right? Remember, G is the smallest one that we can have. So this point up here is the O, which is not at the G sign. So really what ends up happening is you're doing IG equals I about O, right? And then you're subtracting the MD squared there. Okay, more questions? Yeah, what Tommy put up there, the MR squared over 2 minus M 4R 3 pi over 2. Yes. Sorry, I didn't realize that one wasn't in there. Yeah, I'm not sure that what that would be for, Megan. That, oh, I see. See how it says R to the 4th? Right, so that would actually be the area moment of inertia. And that's even about a different axis. What that is a bending moment, and it's not about the CG either. So I see where you had looked for that. Trying to hold on, I put my pen somewhere. Right, that's basically what you were looking at in the book. That's for this, and that's if you have this one here, that's an X, and then that's a y, right? So that's not that's a area moment of inertia. Yeah, it'd be the one in the back of the book. We'd give you normally that. I think we had one on a final 212 exam a while back, and we gave you what it was. Okay, more questions. Yeah, so the disc in the second one, right? So that's here, right? So it is going to have one, right? Otherwise, it's never going to move. Right? How do I tell? Well, actually, maybe the better question is, how can I tell if it has an alpha or not? Because there's a chance at 0. How do I know if it's got an alpha or not? Yeah, you look at the moments, right? So if there's a sum of moments, right, if there's a net moment, there's a net alpha, right? Just like if there's a net force, there's got to be a net, a net acceleration of the center mass. I would tend to go to O, just because you know that it's going to be right. So you know that the acceleration is going to be R alpha going that way. Okay, it's probably just some trig, right? Because what are our forces? Um, an AY for what point, Megan? Yeah, what do you think? Yeah, you'd be right, because think of it like it's just a wheel that's rolling, right? Because that's really what it is right now. It's just kind of a wheel rolling along. Okay, more questions? Um, just the pin forces here of AX and AY as a function of theta. Right, and then do your handwritten ones as well, of course. Do out your handwritten equations. Okay, more questions. Okay, more. Yeah, it would be incorrect because as you see up here, right, if we look at this relationship right here, remember VA still has a value. It's just constrained in the A. It's not a pinned problem, right? Does that make sense to you, Tommy? Oh, VGY, I'm sorry. Yeah, I mean, you're going to get that, right? Because you're going to end up saying omega K, right, crossed into R of, let's see, what do we have? 0 point, I'm sorry, 6.5, right? And it's going from A to G, so that's going to be a minus sign, and I, and then plus 6.5 in the J. So, it's not quite omega R, right? It's going to be really the omega times, and these are going to be, here, let me just redo that whole thing. So it's omega K, and then it's going to be crossed into, will be 2.5 in the J hat, right, so that one's right. And then it's going to be like a 6.5 times a cosine, right? Whatever that ends up being. Did you get your x?
Hello?
Yeah.
Yeah. One more time, what were you asking?
The x from A to G. So Ethan said 4.5.
Yeah, it's sorry, it's -6, right?
So it's,
Position 2.
yeah, it's going to be whatever. So this is 6.5. This is 2.5. So it's whatever that x is, right? Okay. So does that answer
Yeah,
what
and
you're
then when you do the cross product of that, you only get one thing, like VA doesn't have a J hat, so you get
Yeah.
so VG.
Yeah, you're right. So you're just going to have the only you won't have another component. Yeah.
And you can't plug that into the work energy equation directly.
No, because you do have a VGX as well, right? So if you look up here, right, you have a VGX. Unless you get, VGX is going to be this plus whatever you get from that cross product.
Okay.
Because this is what you found, right? So you need to use another one of the expressions to figure out what VGX is.
Yeah, and then I did that, and I got I did G to B, and then I got all 4 equations and 4 unknowns. But when I was solving it, I would end up with omega is not 0.395. So I guess it's just math error.
Yeah, I mean, I think I ended up doing, trying to figure out a VGX one. What did I do? I kind of went. I did like what you did for the VGY, right? And then I think the VA, I ended up using this one and being able to pull that one back up into here. So, but then you got to throw in the VGX squared plus the VGY squared, right? So, because really the VG squared, and that's what you're looking for in the end, right?
Yeah.
Is going to be this. So, yeah, probably just some math somewhere.
Okay. Thanks.
Sorry. And remember, you guys, this is only, each of these is only worth 3 points. So if you've got the methodology down pretty well and you're just not quite getting that final answer, don't spend hours upon hours of it. You're probably going to get most of the points, and then we can sort of talk about it sometime if you want to figure out.
All right, cool. Thanks.
Okay, Lauren's asking about this one here, right? So, well, how are we going to figure out what AG is, Lauren? Kinematics. So what point would I go to? Yeah, so if we go to AO, then I have a plus omega cross R from O to G, plus I have an alpha cross R GO. Right, so do I have an omega? Yeah, do I have an R between O and G? Yep, so do I have a normal component? Yeah, you will. Okay, and I mean, we kind of, so many of these problems we end up saying, oh, it's starting from rest. So you kind of get, unfortunately, in that little habit of saying that it is that the omega 0, but for this one, it's not. Yeah, so it's AY. Sorry, it's A of O in the Y direction equals 0. Just for point O. Okay, any other last minute questions? Yeah. Let's see. Is that 4? Okay, I'll check back in a little bit. You can ask me to go to different ones. Yeah, it's kind of too bad. The old thing I used to use, actually, you guys could go back and forth between whatever notes pages you wanted. And so Zoom's still pretty good, but it's not quite as good as that old one that I had. Okay, so I'll leave this up. I'll check back and go to a couple other pages in about 10 or 15 minutes. And then I'll end up closing out so that I can make the recordings too.